Hey guys, welcome back in. Mr. Marone here. Welcome into Chapter 10. We're going to be in Chapter 10 for a while. There are 8 sections of Chapter 10, and Chapter 10 is all about circles. The whole focus of this will be circles, and we'll see how it goes. There's a lot to do with circles. I think this new flipped mastery model is going to really lend itself well to circles because it is so tough. There's just so much stuff in this section. So right off the top, just encouraging you that it's going to be a bunch of work. You're going to do great. Everything's going to be fine. So let's dig in. So if we do just a quick recall, a circle is a figure where all of the points are equidistant or of equal distance from a central point. And then we had two things that we've used over the course of however many years you guys have been doing math. The first is the diameter, where we connect, it's a segment with endpoints on the circle that goes through the center. And then a radius is a segment from the center to the edge of the circle. And we do know that the radius is half of the diameter. So just a couple quick other reminders. How many degrees are in a circle? That would be 360 degrees. And then the formula for circumference of a circle, or the perimeter of a circle, is pi times the diameter, or 2 times pi times the radius. Okay, now for some new stuff here. We're going to be talking a lot today about measuring portions of the outside of the circle, as well as what is known as arcs, or, a section of the circle based in degrees. So we're going to look at portions of the circumference, but we're also going to look at arcs, which are portions of our degree measure. So a central angle is an angle formed at the center, and it kind of captures part of our circle. So it's an angle whose vertex sits at the center of a circle. And when we create one of these central angles, it creates different arcs, or portions of our circle. We've got 3 different types, really. We've got minor arcs, we've got major arcs, and we've got semicircles. So minor arcs are less than 180 degrees, and they are noted with 2 letters. So in my example over here, my minor arc is called arc AB, and we just put an arc over top of it. Now, our major arcs are more than 180 degrees. And they're noted with 3 letters. So that's how you can tell right away whether you have a major or a minor arc, based on the number of letters given. So in our example over here, this is arc ADB. It travels from A around to D, and then all the way around to B. And the reason why we switch them up and we have major arcs having 3 letters is it tells us which direction to go. We're all lazy people, including mathematicians, so if I'm told go from A to B, I'm going to take the shortest path. So if I want to go from A to B through D, I have to denote that. So major arcs have 3 letters. And then a semicircle is exactly 180 degrees. And we use 3 letters for that as well. So once you have 3 letters, you'll have to determine whether or not it's a semicircle. But the secret is, as long as they give you a diameter, you have a semicircle. So when it comes to measuring arcs, when we're dealing with central angles, the measurement of the arc matches the measurement of the central angle. So in this case, my minor arc would be 60 degrees here, and my major arc would be whatever's left over, in this case 300 degrees. And we're going to take a look at an example down here. So all of these are central angles, and they want to know what is these following 4 measures. So they want to know arc BC, so for my traveling from B to C. If you notice, the central angle is 80 degrees, so that means my arc is going to be the same measure. They're identical. So arc BC is going to be 80 degrees. If they wanted angle 1, it shows that angle 1 kind of captures arc AB. And arc AB was 70 degrees, so once again, they're exactly the same. Now, if we want arc AC, that goes from here all the way down to here, we just add them up. 70 and 80 gives me 150 degrees. And then my final piece that they're looking for is A to D and then all the way around to B. So you have a couple options. You could figure out what arc AD is and then add up all the pieces. Or if you notice, from A all the way around to B through D leaves the entire circle minus 70 degrees. So we could take 360 and subtract 70 and get 290 and save ourselves all that extra work. If you wanted to figure out what AD was, you could. It's just not worth the time. So let's take a look at the other portion of this, the other idea of this, which is finding out what the actual measures of a side are. So before we were looking at angle measures. What portion of a circle did I have? And that's what you had for arcs. When we're looking for arc length, that would be as if I were to cut out a portion of the circle and stretch it out straight like a line segment. That's what we're looking for. And we have a formula to do that. We're going to take what portion of the circle in degrees that we have, and we're going to multiply by the circumference, which is just pi d or 2 pi r. So in this example here, it says a circle with radius of 4. They said, what is the length of the arc where we have a measure of 80 degrees? So right here, I'm just going to make this 80 degrees. And they want to know this arc right there. They want to know that arc. So using our formula, our arc length, which is denoted by the letter S, is my 80 degrees over the entire circle, 80 over 360. And then I'm going to write my formula for circumference, which in this case they gave me radius. So I'm going to do 2 times pi times our radius of 4. And at this point, we're going to leave everything in terms of pi. We're just going to make life a lot easier and not multiply by pi. Pi is always going to give us a decimal, so we're going to try to avoid that as much as possible. So what I'm going to do here is I'm going to simplify this. So I'm going to simplify the fraction, and I've got 8 pi on the other side, and we're going to multiply those together and leave it in terms of a really weird looking fraction with pi in it, all that kind of stuff. That's all good. So in doing that, 80 divided by 360, when we simplify that fraction, is actually 2/9. So when I multiply these, I've got 2 times 8 is 16 pi over 9. And that right there is my final answer. It looks really weird, but it was a perfect answer. That's an exact answer. We don't get a decimal there. One thing that's brand new that we're going to introduce, and we're going to spend time with it so you're not going to have to panic if it's like this weird thing, is we're going to introduce this idea of a radian. And a radian is equal to the measure of a central angle that basically splits the side of a circle so that it matches the length of a radius. Okay, so it's kind of a weird thing, but basically if I have length r, the portion of the circle that we cut out that matches this length r is going to give us our radian. And we have a couple shortcuts here, and this is why we switch our calculator to degrees when we dealt with trig. If we have a circle and we know that we have 360 degrees in a circle, when it comes to radians, there are 2 pi radians in every circle. And there's a whole proof for that, which I won't get into. But basically speaking, if you have an entire circle, 360 degrees is broken down to 2 pi. So half of a circle, 180 degrees, is going to be pi. And the formula for doing this is just your central angle in radians times the radius. So it shortens up the process of doing this little conversion. Really what you're doing here is converting it to radians when we bring in pi. So if I'm looking at this example here, they gave us a circle with a radius of 6, and they want to know what's the length of an arc that has a measure of pi radians. So we know pi is equal to 180 degrees. So I'm going to take that and plug it in for my theta, and my arc length is going to be pi times my radius, which is 6. So my arc length is just going to be 6 pi. Very simple. So I know I just threw a ton of information at you, and I apologize for that, but that's the beauty of these videos, is you can keep going back and reviewing them as you need to. I invite you to bring in any questions you may have, and definitely try some of these practice problems. Have a great day, guys. Bye-bye.